Hey guys, how's it going? So today I'm going to show you how to evaluate any first order linear differential equations. It's actually not that difficult. It's there's a basic formula I'm going to show you guys and you can apply it. So first of all, the general form, gen short for general format of a first order linear differential equation goes like dy dt, or y prime of t, dy dt plus p of ty is equal to g of t. And basically, yeah, so first thing, yeah, so p of t and g of t depends on t. It could be constant, but it might not be. The coefficient for y prime of t should always be 1 when you're applying this formula. When applying the formula I'm about to show you, it's not really a format where it's an algorithm, but let's go about it. So first off, I am going to, let's solve this equation. So 4 plus t squared, 4 plus t squared, dy dt. My pen's a lot better now than before. Before, it was like what happened was my mouse would double click. So a lot of the times this wouldn't register, but it seems to be doing better now. Okay, plus 2ty is equal to 4t. It's not in general form yet. We have to divide both sides by 4 plus t squared. So dy dt plus 2t. I like to usually have the leading coefficient at the front sometimes, so I'm just gonna do this. It doesn't really change the equation that much. So plus over t squared plus 4, y is equal to 4t over t squared plus 4. All right. So let's label our p of t and g of t. So the way I'm going to show you how to solve this equation first, and then I'll show you the general format of doing it. Okay, so p of t is equal to 2t over t squared plus 4. And g of t is equal to 4t over t squared plus 4. All right, now what we have next is we need to find something called an integrating factor. There's this thing called mu of t. Mu of t is the integrating factor. And the formula for that is e to the power of, or exp, that's another way of saying e to the power of, exp of, or e to the power of, the integral of p of t dt. Yeah, so let's figure that out. So the integral, the antiderivative of p of t is just ln of t squared plus 4. So that's just here, it's just exp of ln of t squared plus 4. So this is just e. So this is just e to the power of ln t squared plus 4. That's basically just t squared plus 4. So that's t squared plus 4 is the integrating factor. Now I'm going to highlight all these because now I will give you the formula for solving it. So the algorithms, finally, the formula where you put it all together. Y of t, this goes for any first order linear differential equation that's in this general form. Y of t is equal to 1 over mu of t I'm going to give you the general case before I, okay, y times the integral of mu of t g of t dt plus c. And applying that here, so mu of t is t squared plus 4. So that's 1 over t squared plus 4 times the integral of, so mu of t g of t, mu of t g of t, yeah, so what was it? Mu of t times g of t is going to just be 4t dt plus c. Plus c. And I'm just going to write this down as the final punch. This is the answer. Y of t is just equal to 2t squared, because that's the antiderivative of 4t. So 2t squared over, 2t squared plus c over t squared plus 4. So yeah, that's basically the general form of how you do it. Let's do one more. Let's do one more just for the sake of you guys getting familiar with this. But before I I encourage you guys for the next question, because it's going to be a similar style, to pause the video and try it on your own and see if you get the same solution as me. All right, so the second one, dy dt, this I think is easier. Plus 1 over 2y is equal to 1 over 2 e to the t over 3. This is basically how I do math, guys. I have an algorithm and a way like of doing things systematically. It's like learning, it was like learning parallel parking, you know, like parallel parking was a pain in the neck. But like I followed the certain algorithms and certain steps, and then I kept repeating and repeating. After doing about 100 of these, it's almost like second nature. So first identify your P of t and G of t. So P of t is a constant. It's 1/2 in this question. And G of t is 1/2 e to the power of t over 3. Yeah. So we have that. Now mu of t is equal to the integral mu of t is equal to the is equal to exp, the e to the power of exp of p of the integral of p of t dt. And that's basically just e to the power of t over 2. Yeah, because 1/2t. Yeah. That's your mu of t. Now we plug in the regular formula for y, and y is equal to 1/mu of t (1/mu of t) times the integral mu of t g of t dt plus c. All right, and that is equal to 1/e to the t over 2. That's e to the negative t over 2. And mu, so e to the mu of t times g of t. So 1/2 e to the t over 2 times e to the t over 3. So 1/2 plus 1/3, that's 5/6t e to the t 5/6, so 5t over 6 dt plus c. And when you solve that, that's equal to, okay, so actually, no, not like this yet. So that is equal to e to the t negative t over 2, wait, e to the negative t over 2 times 1/2 1/2 okay, so 6 over, yeah, times 6/5 e to the 5t e to the power of 5t over 6 plus c e to the negative t over 2. So basically y is y of t is just equal to 3. Okay, let me think. Yeah, because 6 divided by 2 is 3. This is in my notes. That's just equal to 3/5. 5/6 minus 1/2. Yeah, e to the t over 3. Plus c e to the negative t over 2. And let me see, do I wanna, yeah, I think you got the basic gist of it. So if you want, I will set up one question for you guys for you to solve. I want you to solve, to do, here's the question I want you to do. 3y prime plus y is equal to at squared. When you get it correct, you should get an answer y of t would be equal to y of t would be equal to at squared. I already did this, so I know the answer. At squared minus 48t plus 144 plus c e to the negative t over 3. This is for your guys' own practice. All right, so that's all on first order linear differential equations. I love to stay, but for now, I gotta jump. I'll see you guys on the other side of the bridge. Catch you next time.